All Things Ansys, a podcast from the technical support staff at PADT. Episode 114, a look at what is new in optics in Ansys 2023 R1 and an update on the world of Ansys. Hi there. Happy February to everyone. Where did January go? I don't know about you, but I feel like most years I sort of ramp up in January, lots of planning and such, but this year we hit the ground running at full speed and the months just came and went. My name is Eric Miller. I'm one of the owners here at PADT. I'm your host for these podcasts, and I'm recording this on a Sunday afternoon in under blue skies in Phoenix in my backyard. So that's what the fountain, if you can hear it, the fountain or the planes or the birds or the cars going by is. So welcome to the podcast. So as mentioned in our last episode, we took a very long break and are back now, moving on to one episode a month instead of two a month. And since some of you may be new or may have forgotten, it's a good time to introduce or reintroduce PADT and myself to our listeners. So PADT is an 87-person company-ish. I think we're going to add a couple people in a couple weeks, based in Tempe, Arizona, with offices across the Southwest, that is the leading provider of products and services to companies that design and manufacture products. We started the company back in 1994. That's our 29th anniversary is coming up next month. We took three core computer-aided engineering technologies that we were using at what was then Allied Signal Engines and is now Honeywell Aerospace, and built a consulting company around them. It was simulation, advanced design, and advanced, kind of new at the time, 3D printing. A few years in, the vendors who were providing us with those tools asked us to become resellers for them. And that is how we became an Ansys channel partner and started selling Stratasys equipment as well. Later on, we added Flonex for 1D thermal fluid systems, EOS for metal 3D printers, and the combined Zeiss and GOM optical and laser scanners. We continue to provide services with teams dedicated to product development, simulation, and 3D printing as a service. Now, you can learn more about PADT at www.padtinc.com, padtinc.com. That's our website. And most of you know us for Ansys, but we do much, much more. So please check us out and consider us as your partner for those things. And as I said earlier, I'm Eric Miller. I'm one of the founders and owners of PADT. And my current responsibilities right now are heading up our design and simulation consulting team, although our VP of Engineering, Tyler Shaw, does most of the work there, as do the employees that work in that group. I also manage HR, IT, facilities, and company marketing. Outside of PADT, I'm lucky enough to be the chair of the Arizona Technology Council Board of Directors. This is a 700-person trade group focused on tech, STEM, and making Arizona a better place for tech people to work and to grow a business. I'm also an entrepreneur in residence at the Arizona Commerce Authority, where I mentor startups going through the Venture Ready program there at Commerce. And the last of the significant volunteer things that I do is I write a somewhat, occasionally monthly column for the Phoenix Business Journal. I get to cover pretty much any topic I want, and it's a blast. I have to tell you, it's a dream come true. So I get to go deep and thoughtful about the role of tech companies in dealing with some of today's biggest social troubles, or take a fun look at living in Arizona, sometimes a little bit of humor. So it's a lot of fun to do that. I do more, including a freelance content writing for other people's blogs and sites. So, drop me a line if you need a writer that actually understands what you do. And I'm halfway through the creative writing certificate at the University of California, Berkeley Extension program. So decided to go back to school in my late 50s, and it's a lot of work. I forgot how much work homework is. And that brings us to some background about me. So I grew up the son of a U.S. Air Force fighter pilot and spent about half my youth here in Phoenix at various bases around Arizona, and the other half spread across either Virginia, Europe, or Sacramento. And I finished my last 2 years of high school in Sacramento, and from there went to UC Berkeley and obtained a bachelor's in mechanical engineering. And when I graduated, I had two job opportunities. One was in San Jose, and one was in Phoenix, both at pretty much the same salary. So I took the Phoenix at what is now Honeywell, the job in Phoenix, well, it's now Honeywell, so I could save up money. My plan was to save up that money to afford to get a place in the Bay Area. Well, I'm still saving that money. I still can't afford to live in the Bay Area. I've got two kids. One is studying philosophy at San Diego State University, and not San Diego State, California State University, San Diego. No, what is it? Yeah, San Diego State University. Yeah. And the other is about to get his degree from the University of Utah in video game design. I'm very jealous of both of them to be studying such cool things and being at such cool schools. Here at home, it's me and my wife right now, and we are down to one dog because Mo, who was the best dog ever, just passed on at 15 years just before Christmas. And we have a tortoise named Bern. He's still hibernating for the winter, so he hasn't come out yet. My hobbies include writing and cooking as well as travel. And that is more probably than you ever wanted to know about me, but I feel like every couple of years I need to get it out there just in case you're wondering. If you want to know more or if you want to interact a little bit more, definitely subscribe or link to, connect to me on LinkedIn. Just search for Eric Miller, PADT, and I'll come right up at the top. I accept all asks. Would love to connect with you. You can see the feed, all the stuff we're doing, all these different things I do, as well as I always copy all of PADT's posts on LinkedIn to that feed as well. So it's a great way to stay in touch and keep on top of things going on in the world of PADT, mine, and a little bit of Ansys as well. All right, like I said, that's more than you ever wanted to know. Let's move on to what you're really here for, which is probably our interview. So on Friday, our PADT's very own optics engineer, Cynthia De La Rosa, joined me on Teams to talk about what was new in Ansys 2023 R1 for optics. And we also talked about Arizona Optics Day, which we both attended the previous week down in Tucson. It's an annual event down in Tucson. We'll talk more about it. And I'll shut up and I'll let her do the talking.
All right, everybody. I want to thank our listeners for joining us on this discussion today. I'm with Cynthia De La Rosa, and we are going to talk about what's new, a couple things around optics for an event down in Tucson that we were both just at last week, and then also what's new in the latest release of Ansys. So, Cynthia, welcome.
Yeah, thanks, Eric. Hi, everyone. I'm excited to be here and excited to talk anything and everything optics and everything that's new in 2023 R1.
It's pretty cool, and I think we're both a little jazzed about it because we were down at something called Arizona Photonics Week, or Days. I always call it weeks, but it's Arizona Photonics Days, and it's a conference before Photonics West in California, where it's mostly Arizona folks, but people from around the world came, and we talk about optics and photonics. And I don't know what your favorite thing was, Cynthia, but mine was hearing from the people doing the experiments on the James Webb Telescope. It was amazing to hear them talk.
Oh, yeah, definitely inspiring, especially, I come from an astronomy background, so just getting to be able to sit in and be there in person with them was just super awesome.
I didn't realize what gods they were until I Googled them. I just thought they were professors at ASU, or at University of Arizona, but no, these are the people behind some of the experiments, right?
Oh, yeah, definitely. I think Marcia has definitely taken the lead on the NearCam stuff. I think that's definitely it's just amazing, right? It's just awesome.
Yeah, the pictures, and I know these are the people that see them first, right, before we get the press release.
I know, post-process and all that.
Yeah, pretty cool. Any aha moments or stuff you want to share with our listeners that you got from that conference?
Yeah, definitely. I think for me, the coolest part was connecting with folks from all over the world. I think it's just amazing that there's so many different optics and photonics clusters in pretty much, not just in the United States, right? We have clusters in our states, but also in different countries. I met Eric, which is the lead in the optics and photonics cluster in Mexico, and he's actually doing, they're actually getting together their own conference down in Mexico in March. And then I also got to meet Madison, which is the executive director of the Canadian optics and photonics cluster. So it was great, just getting to hear the different innovation and technology happening in all these different countries.
Yeah, agreed. I don't know if you got a chance to talk to the guys from Finland as well. They were fascinating. They make some of the coolest lasers out there for medical applications, and just to hear what's going on in Finland in optics was such a small country. They're doing amazing things.
Oh yeah, definitely agree.
Yeah, it's fun. I always look forward to that event, and it's definitely, if anybody listening wants to check it out, we always put it on our website before it happens. But it's basically the last full week in January, usually down in Tucson. And like I said, it's a great stop off if you're going to Photonics West, which is why a lot of people come to it. So I can't wait to see what we learn next year. And I'm pushing them to do more simulation. I gave a talk about PADT, and I kind of called them out that I feel like the industry is a little behind. They're still building a lot of hardware and testing a lot of things in the real world, and they need to go virtual. So hopefully they'll do more next year. We can get some people to maybe get a session on simulation. So I'll try.
Yeah, that's what I was thinking. I mean, we can maybe next year just go up there and do our own technical talk on the different kind of software out there and the kind of simulations that are actually possible.
Have some of the students show some of the work they've been doing, because I know they're using the tools that we're going to talk about in a second. So yeah, I've got that on the agenda. So hopefully next year we'll get it up there and add another half day maybe.
That'd be great. Yeah, that'd be awesome.
Cool. So let's talk about the new release, which is 2023 R1, right? And I know you've had a little bit of a chance to look at it. It's brand spanking new, but what's the number one thing you want the listeners to know about the release?
Yeah, so I think Ansys as a whole is really pushing for, integration of all of their optical software into a nice streamlined workflow. And so that's what each of these individual softwares are really pushing towards. I know Lumerical is really, really pushing forward on getting these different kinds of dynamic links between its Lumerical solvers, its photonic solvers with the optical solver of Zemax Optic Studio.
Cool.
Yeah, and I will highlight with Lumerical, they're really hoping to put a lot of research and development into the quantum photonic world. They're really trying to do a lot of research there in order to help a lot of our customers. I mean, we see a lot of quantum computing, quantum companies out there, and they're a bit limited on the software or the resources that's out there. And so Lumerical is really trying and hoping to bridge that gap with their solutions through some of their multi-physics solvers like Q interconnect and things like that.
That's a really good point, because my view of Lumerical is that it was a group of very specialized and accurate and capable solvers, but not necessarily integrated. And it seems like they're really, really working on that so that we can leverage that capability and use it in a lot of different places. And we heard a lot in Tucson about quantum. There's so much to be done in that space,
Oh yeah, definitely. And they're really pushing for like meta lens applications and things like that as well. And just trying to capture that, very tiny photon level science and physics.
Yeah, which hurts my brain a little bit, I'll admit.
Oh yeah, same here.
I'm literally imagining photons spin, and I was talking to one of the professors at U of N. He's like, they don't actually spin. We just call it that. I'm like, okay, I guess that's true. But as a mechanical engineer, I think of it that way. So that's great, the integration stuff. And what about Zemax in particular? I think most of our listeners are most familiar with Zemax. What's going on with that in the latest release?
Yeah, so Zemax is pushing a lot on the manufacturability aspect of things. So they're trying to find a way to tolerance all of these high-tech, intensive optical systems. And so with this update, they've actually released an entirely new surface, which is a composite surface. And so this surface actually allows you to add multiple different SAG surfaces or SAG profiles. They become additive until you have one final surface that actually contributes all the SAG profiles of each of these other lenses or all of these other surfaces together. And so the importance of this composite surface is that now you can tolerance these very intense, very unique surfaces, which when beforehand, it was really hard to tolerate something like this. And so they're really hoping to help optical engineers kind of bridge the gap between their optical design and the manufacturing processes that come with it. After simulation is done, right, and you're trying to produce your optic. And more to that, they've actually added in export to PADT tool within Optic Studio. So PADT is actually a web-based tool that helps users determine the optical fabrication methods that are out there. Yeah, and the different optical fabrication methods that would be needed for their specific optic. And also, what is the effect on their optical performance and the cost, given their, unique optical design. And so that's actually pretty exciting because they're really, again, just pushing for the manufacturability of all of these optical designs that get designed within Optic Studio.
Well, it's a really important point, because I think, like a lot of physics, and this is maybe something we went through when I started my career in mechanical and then fluids and then high frequency, is we use simulation to design this perfect geometry, and then it can't be made.
Exactly. Or it can be made, but the price just went up, 3, 4, or 5 times.
Exactly. So what can you live with, tweak it a little? That's really good to hear. I mean, it's because of course we see optics everywhere, right? And sensors especially, it's just booming. And I know that they're getting smaller and weirder shapes and all sorts of stuff like that with these new sensors. Yeah. Cool. So that was Zemax. I was actually thinking about the rendering tool. What's it called again? I can't remember. It just kept fell out of my head. SPEOS the other day.
Oh, yeah.
Because I was replacing a light bulb in my son's 2003 Saab convertible, and looking at the lens that it had on there and thinking this was not designed using this tool. What's going on at that tool? How has it progressed, and anything new and exciting?
Oh, yeah. So I'm very excited for this release within SPEOS, because they have actually achieved and kind of pretty much completed their GPU compute tool. So beforehand, we were in beta mode, but now at this point, we're solving through GPU. And I know that a lot of the Ansys softwares are currently, on that front. But this is really exciting, right? Because beforehand, our GPU computing of our simulations, they were faster, but we weren't sure of the accuracy yet. They were pretty accurate to a certain degree, but now the SPEOS team is actually pretty confident that we're hitting, the same accuracy, if not even more accuracy compared to our CPU simulation results. So that's pretty exciting. With that comes the validation of all of the different sensors within SPEOS, and now they can all be used within GPU compute as well. So that also includes the human eye sensor. So that's pretty exciting because those renderings usually take quite a lot of time and effort computation-wise. And so we're just kind of really reducing the amount of time that it's taking us to do all of these different simulations. For example, I did a stray light analysis on a camera with a zoom lens attached to it. And initially using CPU, I was looking at about, I want to say like 14 hours. Like I started it, I went home, came back, I still had to wait a little bit. It just took a long time, right? And once I simulated it with GPU, I think it was like maybe 30 minutes.
That's a huge difference. Yeah.
Exactly. It is just exponentially faster. And so that's very, very exciting.
It's funny because we forced GPUs, which were made for ray tracing and things like that, to solve linear algebra problems on the mechanical side, but it never really dawned on me that we should be using it in our ray tracing tools.
Right?
Yeah, that's amazing. Very, very cool. That's really important to think about. And I also know that there's a lot of research in GPUs now, so those are getting even faster and better. So that's only going to increase. Cool. So, yeah, maybe if I buy a new car at some point, it'll have a headlight designed in SPEOS and be a little bit more efficient. That's it's pretty funny how primitive it is.
Oh yeah, definitely.
And that's the nerd in me is thinking about it from a light simulation standpoint as I'm putting the light bulb in, and of course the plastic is broken, so it's wiggling a little bit, and I can see the shadows of the lens on the wall in my garage. So yeah. Pretty funny. Okay, so those are the three big products, right? Lumerical, SPEOS, and Zemax. Is there anything else out there in any of the smaller products to mention, or anything about one of those three you want to bring up?
Yeah, so the STAR module, right? So
oh yeah.
It is now part of Optics Studio as a whole. It's no longer, its own standalone module, but nonetheless, they're putting a lot of research into it. And what I'm excited about for this release is that beforehand, rigid body motions and deformations that you got from your FEA analysis would be coupled together. And so when you looked at your optical performance degradation or the effect of your FEA on your optics, you would see the two, but you wouldn't understand if you're looking at rigid body motions or the deformation of your optical surface. And so they finally decoupled that with this release. And so that's really exciting, right? Because now the optical or mechanical or optomechanical engineer just has to ask, should I worry about my components moving, right? Because that might be more of a mechanical approach and how to fix it. Or should, they worry more about the deformation on the optic, because those have two very different approaches on how to correct for them.
Good point. Because one was probably in the past was just applying the deformation, didn't care where it came from, right?
Exactly.
So now you can you can separate the two out, and that's really, some of our listeners who are not optics people but may work in the electro-optical place, divert a little bit here. Why don't you explain what the STAR module is? Because I'm not sure everybody's aware of it, and I think it's a really important tool for people doing electro-optical design or mechano-optical design, electro-optical design. Yeah,
of course. So the STAR module is bridging the gap between the optical engineer and the mechanical engineer. So it's actually an FEA results import tool. So what it does is it takes the FEA results from a mechanical FEA run or simulation, takes the data, extracts it, and then really simple. It's like really quick and easy, really user-friendly. It imports that data into Zemax where you can align the deformation to the optical surfaces. And from there, you can kind of see the effects of FEA on your performance and whether it degrades or not, or whether, you have to take, some adjustments into your design in order to compensate
for it. Very, very useful. Yeah. So that's always something to think about if you're on the mechanical design side, but you've got lenses and mirrors and things in your design, or if you're on the optics side and you're like, how the heck do I get the results from that simulation that somebody did for thermal stress into my model or motion in my model? So yeah, it's a product that I think the people in the Zemax world kind of knew about it, but they weren't. I don't know. It seems like I kind of stumbled on it. Like, I didn't know that was there. That's pretty cool. So, yeah.
Oh, yeah. It's really exciting. And just from experience, engineers tend to make their own code for things like that, right? So that was my assumption. Yeah. Yeah. There's a ton of open source, but also people just having their personal code in order to do this kind of data transformation. But now that it's readily available through Zemax Optics Studio, it kind of really saves companies time and effort because you don't have to start from scratch. It's there. It's easy. You just got to use it.
I had my own piece of code to fit. I forget what it's called, but it was with a Z surface. So fit deformation on a lens through some sort of a polynomial curve that the old Zemax used to read. That's back in the day. So yeah. Cool. So that's STAR. Anything? That's like your last bit of. Check this out to our listeners here before we wrap it up. What else do they need to look for in the new release?
Yeah, definitely. Something that is pretty cool that the Lumerical team has been working on is the new Ansys Optics Launcher. And I can kind of foresee this being a part of the launching process in both SPEOS and Zemax as well. But for now, it's just in numerical, but it provides access to trial licenses to these other softwares or these other solvers within numerical as well. So it's pretty cool because it's, it's all right there when you just open up whichever solver that you're trying to use within numerical. And it also shows the application gallery, which provides all these different examples that include all three of the optical products as well. So if you open it up and you're thinking, hey, I want to try a different design or a different approach, or you just, have time to have fun and play around, it's really simple to have access to all these different resources from, again, all three, right? Numerical, Zemax, and SPEOS.
That is good to know. That's good to see that infrastructure build is these three, totally separate companies, right, that were acquired or starting to work together and under the Ansys, the one Ansys umbrella, and the benefit of that is starting to pay off. Very cool.
Oh yeah, definitely, especially on the photonic and the numerical and Zemax side, because photonics is waveguide world. It's the realm of a wave and this structure of light as a wave. But then you also have Zemax, which is more on the ray tracing side, and so connecting the two is important. And people are doing these analyses either by hand or with their own code. So now that the two are together, it's really gonna offload the work that optical engineers out there are having to do themselves, because this software will provide that simulation for them,
and hopefully move away from doing everything on one of those floating tables in the real world and do more virtual, which is what I'm hoping for.
To be fair, I love optical alignment.
I know.
Optical metrology. Anytime I was in the lab, I was having a great time until I wasn't, right?
So you couldn't get it fixed. Yeah,
exactly. You can only take so long being in a very dark room with lasers shining everywhere, but
turning those little knobs, right?
Yeah, and you just got to be extra careful. Just don't bump anything. Don't breathe, please.
That's right. Don't breathe things. It's cool, and it's an exciting time for optical simulation, and I think some of the stuff you talked about is the maturity that's coming, and moving from these academic codes or in-house codes and a collection of different solvers and putting them together and providing a common interface and working with other physics within the Ansys family. It's cool stuff. Well, as you can tell, people that are listening, we love to talk about this stuff, and Cynthia just is a true expert in this area, and I really appreciate you taking the time and make a call. If you want to ask your own questions of our team here and learn a little bit more about whatever aspect of optical simulation is, do reach out by email, and we'd love to chat about it because, like I said, there's a lot coming. So thanks for your time.
Yeah, thanks, guys.
We'll talk to you soon. Bye-bye.
So as you can see, things are really coming along for optics, and I think we are going to see the same progression of the tools we saw for electronics, for fluids, and originally even for structures. When we first started with structures, there was quite a migration from this kind of academic expert tool to greater capability, to more usability, to integration across the platforms and ease of use. All those things keep on getting better and better, and we're seeing that in the optics world as well as we bring these tools together. So keep your eyes out for that. And then you can always check out our website at www.padtinc.com or email us at info@padtinc.com if you have any questions about anything that Cynthia talked about today. Now, normally we do a commercial now, but I feel like my long diatribe about PADT and myself was enough of a commercial, so we'll just reiterate, we're available to help you. We do a lot more than just Ansys reselling and consulting, so please do check us out and consider us to help you out. 3D printing, design, manufacturing, consulting, whatever you need. All right, let's move on to the news. So Ansys stock. January saw some growth. ANSS, which is the symbol for Ansys, went up from 240 to 270 in January, which is a nice monthly growth. It's a 12.5% growth for the month. On Friday, February 3rd, it closed at 275, so it went up another $5. And on Thursday, it was actually up 282. So it had a little spike there before a little bit of selling off at the end of the month, in the week. So it closed up 14% for year to date, which is pretty good. And the S&P 500, which is what we like to compare it to, was up 8.9%. So it's back to outperforming the S&P, but it's 1 month. We'll see what happens. I think it would be kind of good going forward to compare maybe a 12-month trailing. I haven't done this before, so I'm going to try this out. By the way, this was a lot easier to look at the stock when it just kept on going up. When it's up and down, it's a lot more work. But trying to figure out what's useful information for people listening. But I think looking at where we were a year ago is kind of and then what happened over that year is kind of a good thing to look at. So I'll start doing that in these podcasts. Anyway, the stock is down 16% from the same time in the beginning of February in 2022. So 16% Ansys net drop, and there was a 7% S&P 500 drop over that same time period. The min over those 52 weeks was $200 a share, and the max was $341. So we're kind of smack dab in the middle of that. Hopefully we'll get back up to those above 300 numbers pretty quick here. They're going to release, Ansys Inc. is going to release their annual numbers on February 22nd, so you can hear the CEO Ajay and his team talk about where they're going and what they did and what the numbers were. So if you do care a lot about Ansys, then I really recommend you listen to that recording of that when they release their numbers, or read the release numbers and listen to the recording of the investor call. It's really good stuff, and we will cover it here in the March podcast. Anyhow, not a bad start for the year. Let's hope it keeps going. Now, if you're a regular listener, you know right before they release numbers, Ansys doesn't release any news, so there's no news that came out. And we are not blacked out at PADT, but nothing happened of significance at PADT since we last talked, although, that's not really true. A little fun thing we did, we celebrate National Whatever Day once a month. So we pick, these websites to talk about, National, Blade of Grass Day, or National, Rose Day, or whatever it is. So last month in January, we picked National Peanut Butter Day. And people brought in peanut butter based bakes, and boy, it was really good. If you like peanut butter, we learned we only have one person with a mild peanut allergy in the company, which was good to know. So that was all safe. She just stayed out of the break room. But that was some good stuff. The winner was were these peanut butter clusters that Miles, who's been on the podcast before, he's one of our Flonex and Ansys experts. He's a support engineer in Ted Harris's group. He made these peanut butter clusters that were just to die for. They were so good. Now, I made a peanut butter cheesecake, and a lot of people aren't into cheesecake, so it wasn't as popular as Miles's was, although I'm going to beat him next time. But anyway, it was one of the best cheesecakes I've ever made. It was really, really good. Huge fan. So it's a lot of fun to do these things, and people really get into it and bring a bunch of different treats. And even if you don't cook, you get to eat. So it's a win-win for everybody. So see how much fun you can have at PADT. And speaking of which, we've got some openings. Let me open up the careers page and go over some of them, because some of them are Ansys related, and you may be interested or may know people who are interested. So let me go over to that page here. Scroll down. By the way, it's padtinc.com/careers if you want to check it out yourself. So in the Ansys world, we have an opening in Colorado for an Ansys salesperson. It's account manager in Colorado. So if you're interested, you live in Colorado or want to live in Colorado or are interested in that, check that out. In Arizona, we're also looking for an enterprise account manager. That position is now open, and we'd be really excited to have you join us. And then we have something new, also in Arizona, which is called a business development representative. It's not really inside sales, and it's not really account representation. It's really kind of looking for and finding and bringing new customers in and learning about. It takes quite a while to learn how to sell Ansys, so it's a great way to learn how to sell Ansys. And then once you're up to speed and you do a good job and we all like each other, you can become an account manager and move on up. Some non-Ansys related jobs that you might know someone that's interested in, or you might be interested in, is we're looking for a demand generation marketing specialist to help generate more demand. We are also looking for a couple, this is actually Ansys, but it's down at the bottom of the page. So what kind of engineers are we looking for Ansys? We need an electrical engineer doing signal integrity and power integrity, and that can be in Colorado or Arizona. And also in Colorado or Arizona is a low-frequency electromagnetics application and support engineer. So both the power integrity, signal integrity, and the low-frequency electromagnetics are still open. We'd love to have people join us. We also have an embedded software engineer application position available. So if you're interested in that, please let us know by checking out the website. And that's pretty much it. I'm also looking for I'm hiring a part-time IT person. So if you know somebody here in the Phoenix area that is an experienced IT support person and doesn't want to work for a big company but likes our environment and wants to work part-time, we just need some help dealing with the day-to-day so we can do more strategic stuff with our IT team. So do let us know. We've also got some hiring over on the 3D printing site, so check that out. Would love to hear from you if you know somebody that's interested. All right, publications. The Ansys blog. So I'm sure, unless you're living under a rock, you know that everybody's talking about artificial intelligence, especially ChatGPT. What does that mean for simulation? Well, Ansys is not ignoring all that. They are moving forward in a lot of different ways, and one of the most visible ones right now is basically allowing you to connect your simulations to the machine learning stack on both Azure and Amazon Web Services, AWS. So Microsoft Azure and AWS have these really nice software stacks that allow you to do machine learning on their clusters. And now, because Ansys runs on those, you can connect them. So they wrote an article about it. It's called Prepare for the Machine Learning Revolution with Emerging MLAAS Capabilities from Ansys. That's machine learning as a service capabilities. So it's in its starting phase. If it's something you're interested in, if you're doing research around, do check it out. If your boss is bugging you, your CEO is bugging you, how are we using machine learning in this simulation stuff? Check it out. It's pretty cool. And then the next article I recommend on the Ansys blog is from SKF. And yes, that SKF, the people that make bearings, they partnered with Ansys to include a bearing selection tool in Ansys Mechanical, which I don't do a lot of machine design anymore, but when I did, oh my gosh, I used to live in that SKF design guide. To have that built into Mechanical is going to be wonderful. So it's the title of the article is Bearing Calculations No Longer a Lot to Bear with, get it? Bear with easy to use automation tools. I didn't realize the pun until I read it just now. It's pun aside, it's a really good article. And if you work bearings, it's pretty useful stuff. So check that out. And the last article I'm going to pick to highlight in the Ansys blog is called Models Behaving Badly Cost Millions, Finding Solutions with BEE. Now, I didn't really know what this was from the title, so I dug into it a little bit. And there's a new product that Ansys acquired. It's called Model Center, and it's basically an optimization simulation management platform. It has a lot of capabilities in it, and we'll have to have a couple of our engineers that are using it come on and talk about it because I haven't been exposed to it too much. But it's a really cool tool, and they have a module within it called, what is it called? It's called BEE, which stands for, I didn't write down what it stands for. Anyway, you have to read the article to find out. Oh, no, it's Behavior Execution Engineer. And so you got to check it out. I don't have my head 100% around it, but basically what it does is if you get running a bunch of runs and the results aren't making any sense, it uses some advanced algorithms to figure out what's going on and kind of tame things down a little bit. So yet another way that we can take our component or single physics simulation, plug it into a system, and do some pretty cool stuff. So check that one out. I think it's worth knowing, even if you don't have a plan to use it right now. It's good to know it's out there. On the PADT blog, we put out a couple of blog posts, and by the way, we finally fixed the fact that we couldn't do blog.padtinc.com because we got our URL padtinc.com way back in the early days of the internet, and over the years our entry in the registry got kind of messed up, and we just couldn't figure out how to do it. Well, we finally fixed it all. It's all cleared up, so we can now do whatever.padtinc.com now instead of just www, which is pretty cool. So blog.padtinc.com now works, by the way. Anyway, articles. Chris Sattini posted a useful article on sensitivity analysis in Flownex. It's a great overview of how you can use Flownex to understand your system much better. His articles are great, and any of them are good to kind of get a feel for what Flownex can do as a 1D fluid thermal systems code. Then Joe Woodward turned a tech support question that he got into a really useful blog that I actually found useful and I will use in the future. And it's called Checking the Tangency of All Surfaces in Ansys Space Claim. So, you don't want any sometimes you want sharp corners, but in general, when you import geometry or you're modifying geometry, you want to make sure everything's tangent. You don't have any gaps. You don't have any sharp corners. So he shows you how to do that. It's a little script that he wrote. And then and because it's a little script, it's also a great example of how to use customization in Ansys Space Claim. And then I did a little post about a tool that we used to have on the Ansys store. It was our PADT's thermostat controller and ACT extension. It's a really long story about why it's not there anymore and why it's back here. But basically, when Matt Sutton left PADT, we let his PID ACT extension lapse on the store, and so we took it down. It wasn't compatible any longer with the new versions. And actually, we used it, but we didn't think anybody else used it, so we didn't really worry too much about it. Well, it turns out a lot of people use it. Once we took it down, we found that out. So Alex Grisham stepped up and got it working with 2022 R2. And we will keep adding to it and keep it up to date as time goes by. It's a really useful tool. And the new blog post I just added links back to the originals about how to install it, as well as Matt's explanation of how it works. It's a great example of how to write an ACT extension, as well as how the PADT controller in Ansys Mechanical APDL works, and how you can create an ACT extension to use it in your mechanical models. So pretty cool. That's it for blog posts on the PADT blog. We do have an event side of things. We've got a webinar coming up. Structural in Ansys 2023 R1 will be on February 15th. Also, all next week, I will be at AME West, the former Pacific Design Show, or MD&M West, whatever you want to call it. But it's a big engineering show in Anaheim, California, right next to Disneyland. It's February 7th through 9th. We have a booth. It's right smack dab in the middle of the floor. I think we are actually in the exact middle of the floor. So do stop by and say hi to us at the PADT booth. And then also be doing 2 presentations. I think it's on Wednesday. I can't remember if it's Tuesday or Wednesday. I should probably look that up. I'm talking about the work that Alex did for NASA as part of the SBIR. STTR we just finished for NASA. And it's an optimization capability that he developed for doing multi-physics optimization, and then shape optimization. And then I'll also be leading a panel talking about workforce development for advanced manufacturing, as we bring all these manufacturing jobs to the U.S. and automate a lot of that manufacturing to make it cost effective. We're running into issues with finding the right people. So that's what we're going to talk about. Got a group of 4 folks who do that for a living, and we're going to have a chat with them. So if you're at the IME West this year, please do stop by. Please come to our talk. We'll see you there. And then the only thing I've got on the agenda right now that's worth mentioning is in April we'll be at the Arizona Space Industry booth at the Space Symposium in Colorado Springs, one of my favorite events. And that's it. I want to thank you. We hope you stick with us even after such a long break. I was looking at the numbers, and actually our download numbers look pretty good. So people did not unsubscribe from our feed, so that's good news. We'll see what happens now that we've restarted publishing again, if we can get those numbers back up. Don't forget to subscribe to our newsletter so you can see all the things that are going on in the PADT at www.padtinc.com/opt-in. Do spread the word. Let people know about this podcast. And as always, do not hesitate to reach out. Thank you for joining us for the All Things Ansys podcast, episode 114. As a reminder, this podcast is not affiliated in any way with Ansys Inc., and the opinions expressed are those of the people on the show only and not of their current or former employers. For more information, visit www.padtinc.com/blog, and please share your thoughts and questions through an email to podcast@padtinc.com. See you next time.